VM. That EC2 instance is nothing but a VM. Here we have some operating system. We have taken Ubuntu, and on top of that Ubuntu OS, on top of that Ubuntu OS, on top of that OS, we have installed Docker. So Docker is a containerization runtime, containerization software. Using Docker, we can build, we can ship, we can run our applications as a container. And that container contains everything. Everything in the sense, whatever is required to run your application. Required softwares, required configuration files, required environment variables with your code. So wherever you want to run, you can run that package seamlessly in any environment. So when it comes to Docker architecture, we have three important components. We have three important components. What are those? As we discussed yesterday, we have a client, we have a client Docker CLI client, and we have a Docker daemon, Docker daemon, and we have something called registry, registry, registry. So in the interviews also they are going to ask what is Docker registry, what is repository, like that. First let's understand what is that registry. Docker registry or registry. So what is registry? In general, sometimes in the interview they are going to ask this question. What is Docker registry? What is Docker repository? Or they may ask something like this: registry, difference between registry and repository. Repository. So we guys already used the registries, repository concepts. So what is registry and what is repository? Anyone has any idea? We already used these things. So we already used this registries, repositories concept, right? So registry and repository, these are two different things. So in simple words, if I have to say registry, registry is a collection of repositories. Registry is a collection of repository. Registry is a collection of repositories. So registry is a collection of repositories. So repository is a collection of what? Swati is saying repository is where we store the code. I am talking about not SCM repository. SCM repository is different. This repository is different. In SCM repositories, you are going to store the code. Suppose you are using Nexus, you are using JFrog. Are we going to store the code in the Nexus or JFrog? Are you going to maintain the code, source code in the Nexus, in the JFrog, like that? No. So that Nexus repository or JFrog repository is used for what purpose? We are going to store the build artifacts. Guys, please be on mute. In the Nexus repository, you created a Nexus repository, you created a JFrog repository, like that. What are you trying to store in that Nexus repository, JFrog repositories, like that? You guys are storing the build artifacts, the build packages, whatever packages. The packages are artifacts The packages or artifacts we call it. So you are storing that packages in the repositories, right? So registry is a collection of repository. So in the registry, you can create a multiple repository. If you take an example like Nexus, in the Nexus, do you able to create a multiple repositories for different applications, multiple repositories in the Nexus or JFrog? Yes. So registry is a collection of repository. Registry is a central server or central location in which you are going to maintain the repositories. So, so Docker registry is a software like Docker registry could be hosted by a third party as a public or private registries. So Docker registry is a central storage or central server in which we can maintain repositories. So registry is responsible for hosting and maintaining repositories. Repository is a collection of images. So this registry is basically Docker registry. It's a collection of repositories. It's a collection of repositories. It's a collection of repositories. It's a collection of repository. So repository is collection of what? Repository, it's a collection of packages. It's a collection of images. Docker repository is a collection of Docker images. It's a group of images or it's a group of Docker images. Repository is a collection. In repository, we can store Docker images. In Docker repository, we can store Docker images. It's a collection of Docker images of same application with the different versions, different tags. So Docker repository is a collection of Docker images with the same name and have a different tag that have a different tag which means versions, different versions of the same image, same package. Suppose to make things simple, you guys uploaded lot of packages. When you guys practice Nexus, you guys created a repository in the Nexus. You guys uploaded multiple packages. Can we maintain multiple packages of same application with a different version like 1.0, 2.0, 3.0 like that? That versions? Yes. So similarly here in Docker, we are going to create a images. That image is nothing but a package. In the Docker, we are going to create a images. Image is nothing but a package. But that package contains application code along with required softwares also. Along with required softwares, configurations, and environment variables, everything. That package we can store in the Docker repository. But can we create a repository directly without registry? Can we create a repository without registry? No. So registry, it's a collection of repository. Registry is a collection of repository. The Docker registry could be hosted by a third party. Docker registry could be hosted by a third party. Third party in the sense someone else, or you can set up yourself. So you can host the Docker registry by yourself, or you can host the Docker registry can be hosted by someone else. So Docker registry, it's a central It's a central server or service. It's a central service in which we can create in which we can create multiple multiple Docker repositories. It's a central service in which we can create a multiple repository. This registry is nothing but a collection of repositories. So this Docker registry can be hosted by third party. What do you mean by third party? Someone else. Instead of we, that a Docker registry can be configured and set up by someone else. So this Docker registry can be hosted by a third party, third party in the sense someone else, some provider, as a public or private, as a public or private. So we can host as a public or as a private. Now, Docker registry can be hosted by a third party, or we can host the registry by ourselves, or we can host Docker registry by ourselves. Examples for this Docker registries. Example for this Docker registries, there is something called Docker Hub. There is something called Docker Hub. Docker Hub. So this is managed by whom? It's managed by third party. It is managed by third party. What do you mean by third party? Here someone else. So who is managing this Docker Hub? It's a central registry. Docker Hub is a central registry in which you can find multiple public images. So who is maintaining this Docker Hub? As I already told in yesterday's session, we already discussed. In yesterday, we discussed, right? So there is something called registry. There is something called Docker registry. So that registry, there is a central registry maintained by Docker, that is called Docker Hub. This registry contains the Docker Hub registry contains various public images that can be used. And also we can create our own registries. We can create our own registries. So this Docker Hub is a public registry maintained by Docker itself, and we can create our own registries also ourselves. Also we can configure, or this registry can be maintained by someone else. We have some other registries, example ECR, ACR, GCR, like this. What is the meaning of ECR? Elastic Container Registry. It's a service. It's a service in AWS. ECR is one service in AWS. So instead of we manage these registries to store the Docker images. Who is going to manage that registry for us? If I go for ECR in AWS cloud, if I create a ECR, who is going to set up and manage that registry for us? Who is going to maintain the availability, scalability, and storage for that registry? AWS. So it is one service in AWS. Yesterday someone was asking, sir, Docker and Kubernetes, is it a part of AWS or is it comes under DevOps tools like that? So Docker and Kubernetes is a software. Docker and Kubernetes is a software that you can install anywhere. As I already told in the yesterday session, can we install Docker in a local laptop? Can we install Docker in on-premise servers or AWS or Azure or GCP like that also? Yes. So it's a software. It's a software that can be run wherever you want to run. But for what purpose we are using Docker and Kubernetes? First, forget about Kubernetes. Let me explain about Docker. What purpose we are using Docker? To build and deploy our applications as a containers, to build and deploy our applications as a containers. What is the advantage with containers? We already discussed. Containers are lightweight, easy to build, easy to deploy. We can quickly deploy because we are creating a package with all the required softwares and configurations. Wherever you run, wherever you have a Docker, that will work seamlessly. Now, is it comes under DevOps? Yes, because because we are deploying our applications as a containers. So is it falls under DevOps category tools? You are building and deploying that application as a container. So definitely it is part of DevOps only. People are building and deploying that applications as a containers. It comes under DevOps. But do you have some managed services in AWS? I don't want to set up Kubernetes on my own. Do you have some managed services in AWS or Azure or GCP? Yes. So Kubernetes is, instead of you set up Kubernetes, instead of you manage Kubernetes, AWS will manage for us. That is EKS. Guys, we will understand slowly. Don't hurry. Don't hurry the things. We will discuss all these concepts in detail. First, focus on the basics without understanding what is Docker, what is container, what is what. If you directly go to the Kubernetes, you will not understand anything. So focus on the basics. In detail, we will discuss in next 2 months. You no need to worry. I'll take care. But make sure you are attending all the classes. If you don't attend all the classes, if you don't practice, if you don't do the assignments, if you don't go through the recordings or documents, you can't understand anything. Okay. Now, this Docker registry can be managed by a third party like Docker, ECR. ECR will be managed by AWS. If I go for ACR, what is this ACR? The full form of ACR is Azure Container Registry. In which cloud we have this one? In the Azure cloud. In the Microsoft Azure, there is one service called ACR. So that registry can be managed by Azure. We have something called GCR, Google Container Registry. In which cloud we have this GCR? GCR is in GCP cloud, Google Cloud Platform. Now, it's a central service, basically a central software or server like Nexus that can be managed by someone else, or we can host a Docker registry by ourselves using Nexus, using JFrog. This Nexus, JFrog, we can use Nexus, JFrog or DTR. If you are using Docker Enterprise Edition DTR, this Nexus, JFrog, DTR like that. But if you are using Nexus, who is responsible for setting up that registry and managing the registry, high availability, scalability and storage for that registry if you are using Nexus or JFrog? Ourselves. Ourselves. You need to set up that one, you need to manage that one. So in the Nexus also you can create a Docker repositories. In the JFrog also you can create a Docker repositories. I am not sure how many of you observed when Bhaskar sir explained Nexus, you might have created Maven hosted repositories, Maven hosted repositories. Similarly, you might have observed NPM hosted repositories, RPM hosted repositories like that. Did you guys observe there is something called Docker hosted repositories also? Not sure how many of you observed there is something called Docker hosted repositories. So, what does it mean? Can I use Nexus also as a registry in which I can create a repositories to store the Docker images? Yes. But if I am using Nexus or JFrog, who is responsible for configuring and maintaining the Nexus high availability, scalability of that? Ourselves. Ourselves. But if I go for a ECR, if I go for a ACR, if I go for a GCR like that, who is responsible for managing that registry for us? Provider, cloud service provider, CSP. So that is how it works. That is how it works. Now we have a Docker hub. We have a Docker hub. So who is maintaining this Docker hub and what do we have in this Docker hub? This Docker hub is also a Docker registry. Hub is also a Docker registry. This is maintained and managed by Docker itself. Now, in that Docker hub, we have various public images. We have various public images. This is Docker hub images. We have various public images. If you see, this is registry. That registry contains repository. This is one image. This is one repository. In that repository, we contains, as I already told, registry contains repositories. Registry contains repository. What repository contains? What is Docker repository? As I already told, Docker repository is a collection of Docker images with the same name, different versions. Now these staff tags like this, all these are tags. So versions. Now this is one Docker image, Docker package, Docker image, Docker package. So if I create a container out of this package, this image, something will be running in the container. Something will be running in the container. So Tomcat will be running in the container. The Tomcat software will be running is a collection of Docker images with same name, basically same application or same type, same application or type, and different versions that will have a different tags versions. Now Docker Hub, ECR, ACR, GCR like that. But Docker Hub is a central repository. This contains various public images. Like in Maven we have a Maven central repositories. Do we have a lot of third-party dependencies, Maven dependencies in that Maven central repository? Yes. Similarly here, Docker Hub contains various public images which we can use. So is everyone clear? What is registry and what is repository? The difference between registry and repository. This is very, very important interview question. Now, let's understand some Docker concepts. Now we have a registry. In the architecture, we have a registry. This registry can be Docker Hub. This registry can be Docker Hub, or this registry can be ECR, GCR, or ACR, or Nexus, or JFrog, whatever it is. So this registry contains repositories, multiple repositories. Repository contains images with a different versions. Now Docker Hub is a public registry. Docker Hub is a public registry in which we can find various In Docker, we have some concepts. There is something called image. There is something called container. So first understand what is image. Docker image. And later we will understand what is Docker container. So Docker image. What is this Docker image? Basically, it's a package. Docker image is a package. Like jar file, var file. Can I call that jar file, var file also as a package? Like zip file also has some kind of a package, like jar file, var file also has a package. Similarly, this Docker image is also a package. In AWS, we have something called AMI. Can I call that AMI also as a package? In the AWS, we have something called AMI. In detail, we discussed about AMI. Can I call that AMI also as a package? Yes. But these packages are different. AMI is different, Docker image is different, your jar file is different. We call them as a packages. This Docker image is also a package. But what this package contains? This Docker package. So it's a package. We can create a Docker image with required softwares, required dependencies. So we can create a Docker image, the Docker package with the required application code and its dependencies and its dependencies. So this Docker package, the Docker image contains, I can say something like this. Docker image contains everything, whatever is required, to run a piece of software or application. So the Docker image contains everything, whatever is required to run a piece of software or application. So we can create a Docker image with required application code and all its dependencies like required softwares plus configuration files, required environment variables, etc. So image is just a package like a jar file, var file. That is application package. If I create a jar file or var file like that, that is application package. Is that jar file and var file is equivalent to this Docker image? Is both are same? No. Both are two different things. So this Docker image is also a package, but here we can create a package with required softwares and configurations also, along with your application code, along with your application package. So that is what Docker image. Now image is just a package in which we can have required softwares and application code. Now I can share these packages. Or I can maintain these packages in the repositories. So I can create a package like this. I can create a Docker package like this. Let's say something like this. So I can create a Docker package. Let's say this is my source code. From this source code, I can create an application package. Like jar file or var file based on your application, like jar file, var file, or ER file if it is a Java based application. Now I can create a one more package using Docker. That we call it as a Docker image with required softwares, with required softwares, plus configurations, required environment, everything with your application package, your application code, with your application. Now this I am calling it as a Docker image. Now I can store or I can maintain these Docker images in the registries, in the repositories. By creating a repository, we can store these images. In the Docker repositories. Now, if the images are there in this Docker repository, wherever I have a Docker, I can pull this image. And create a container. I will run this image. If I run this image, what will be created? Container will be created. If we run this image, container will be created. Image is just a package, guys. So Docker image is basically a package. Docker image is a package. So if I run that image, container will be created. So what is container now? Container, we call it. Container is basically, it's a runtime process, runtime instance, runtime instance or process. Runtime instance are basically a runtime instance of Docker image. Now let's say I have a Tomcat software in Docker image. If I run that image, what will be running in that container? Suppose let's take this way. I have a Tomcat in the Docker image. I have a Tomcat software in the Docker image. If I run that image, container will be created. What will be running in that container? The Tomcat will be running in the container. So let's say I have Nginx. I have Nginx in the image. If I run that image, what will be running in the container? What process will be running in the container? If I have a Nginx software in the image, if I run that image, what will be running in the container out of that image? Nginx. Suppose, suppose I have a MySQL software. I have a MySQL software in the Docker image. If I run that MySQL image as a container, MySQL process will be running. So image is just a package, and if I run that image, container will be created. Now if you see, as of now, let me connect to my Docker server. I have one Docker server. I hope yesterday everyone is able to install Docker. I hope everyone has installed Docker in one of the server. Now if you see, I have a Docker. Let me SSH to this server. Let me SSH to this server. One second, guys. Let me SSH to this server. We install Docker. So whatever commands we are executing, so the Docker client, the Docker CLI is communicating with the Docker daemon to process these instructions. So Docker daemon is processing the instructions. If you observe, as of now, Docker info, let me execute this Docker info. It is giving information about the Docker. As of now, do I have any containers in this Docker server? Do I have any images in this Docker server? No, because this is just a, we just installed yesterday. We don't have a Docker images or containers. Sometimes in the interview they are going to ask what is the working directory of Docker. So what is the working directory of Docker? Sometimes in the interview they are going to ask this question also. What is the working directory of Docker? So what is the working directory of Docker? If you see here, here you can see, here you can see the Docker working directory or Docker root directory or Docker working directory. What is the Docker working directory? We have varlib Docker. So this is the Docker working directory. Now as of now, I don't have any images in this server. In this server, in this Docker server, I don't have any images. This is the command, Docker images. This is the command. I don't have any images. I don't have any containers also. I don't have any containers also. Now, to create a containers, we need an image. To create a containers, we need an image. Image is a package. Using that image, you are creating a container. Just to make things simple, guys, you guys attended AWS. You guys attended AWS. In AWS, there is something called AMI. In AWS, there is something called AMI. What is AMI in AWS? Forget about Docker. This is nothing to do with the Docker. So what is AMI? Full form of AMI? Amazon Machine Image. So in AWS, we have something called AMI. Amazon Machine Image. What is this Amazon Machine Image? Again, is it a package? Is it a package? It's a pre-configured package. pre-configured package, but what this contains, this AMI contains, which contains operating system and some other settings or softwares. Some other settings or softwares. This is OS package. So when you are creating a EC2 instance, you are selecting AMI. Using AMI, you are creating a server. So does that server will have the OS and other softwares as per the AMI? Whatever is part of the AMI, whatever is part of that package, is that server will have that required OS and other settings also? Yes. Similarly, here we have a Docker image. Similarly, we have a Docker image. But as I already told, does that Docker image contains complete OS? Is that image contains complete OS? No. So image will not contain full OS, but image contains some libraries, some OS libraries to interact with kernel. And also, you can create an image with required softwares and applications. Now, if I create a container out of that image, does that software, that application will be part of your container, whatever is part of the image, whatever software or whatever code you have in the image, will it be part of your container? Yes. So that is what the image and container. Very simple concept only, but I don't want you to confuse. So is everyone clear? What is image? What is container? Now, in Docker Hub, we have lot of images. In Docker Hub, we have lot of images like this. Now I can create a container. I can create a container out of these images. Now if you see, we have Nginx. We have Nginx. We have Nginx. So this is one image. This is one image, Docker official image. So that image has multiple versions, multiple tags, Nginx software with different versions. Now I can create a container out of that image directly. But who created this image? That official Nginx, the Docker community. They have created this image and they have made it available for us. Now I can create a container like this. Docker run -d -name container name, something like this. Nginx container, something like this. Now that image, this is my image. I am creating a container like this. I will explain all these options in some time, guys. I will explain all these options in some time. If you see, I am executing some command, docker run, something like this I am executing. Docker run -d -name, something like this. This is your container name, -p, port mapping. What is this port mapping, port binding? We will discuss in detail. And this image. Now I am creating a container like this. Docker run -d -p, port mapping, -name of the container. This is image. So this image format is like this. This image will be in this format. We have a registry, repository, and a tag. So the image format will be in this format: registry, repository, and a tag. So if you see, we have not mentioned any registry and repository. So what is the default registry in which a Docker will try to download this image, from which it is going to download this image? Docker will point to which registry by default? If I don't mention any registry details, it is going to point to the Docker hub. it is going to point to the Docker hub. Docker hub. So by default, Docker hub is going to find this repository in the Docker hub. Since we have not mentioned the image, that registry details, it is going to find in the Docker hub. Now in the Docker hub, do we have a repository called Nginx? If I go to Docker hub, if I search, do we have a repository called Nginx here? Docker hub? Yes. So in the Docker hub, we have something called Nginx. And we have not mentioned tag also. We have not mentioned tag, which version of the Nginx package, which version of the Nginx image has to be used to create a container. So what is the default tag? These type of questions are common. The default tag is, it is going to take something like this. Latest. So default registry is Docker hub. Default tag is what? Default tag is latest. Now if you see in this, do you have a tag called latest? In this, do you see tag called latest? Yes. So this image will be pulled. This image will be downloaded. This image will be downloaded to that server. Then it will create a container. It will download the image and it will create a container. Now let's say I have a requirement. I want to use this version of the Nginx or this version of the Nginx 1.22 or 1.23.1, this version of the Nginx or 1.23 I want to use. How can we mention that one? Here itself I can mention something like this 1.23. So this image, this package will be downloaded if I mention like this. If I don't mention like this, what is the default one? Colon latest. So in the Docker hub, we have lot of public images. Now this is one Docker image. What this Docker image contains? What this Docker image contains? That contains Nginx. So what is Nginx, guys? What is Nginx? You already know. What is Nginx? Nginx is an web server come load balancer. Now, does that Nginx process will be up and running as a container if I execute some command like this? Now, does that Nginx package will be pulled? That Nginx image will be pulled, and is that Nginx will be running as a container in this server? Containerized deployment? Yes. Now, let's understand these options. Docker run. So, Docker run. What it will do first? Let's understand. Docker run. What it will do? It will create and it will start the container. Docker run will create and it will start the container. So when we are creating a container using Docker run, what is the input for your command? You are going to create a container. So to create a container, what is required? Image. Image is required. Image is required. You are creating a container out of the image. So image is required. This is my image. But where do I have that image as of now? Do I have that image in my Docker server? If you execute Docker images, do you see that image? Do I have any image in this server in which I am trying to create a container? No. Then what it does? What it does? Since that image is not there, Docker image, that Docker will pull this image from the registry. Docker will pull that image from that registry, from that repository. Since I have not mentioned any registry, in which registry it will try to find this repository to download, from where it will download that image? As I told, in the Docker hub. Docker hub. From Docker hub, it will first pull the image, then it will create and start the container. It is going to first check. It will create and start the container out of the given image. If image is not available locally in the sense local registry, the way we have local repository in the Maven, the way we have a local repository in the Maven, understand the Maven concept here also. Suppose you are defining some dependencies, Maven dependencies. If the dependency is there locally in the Maven local repository, is it going to pull that or download that dependency, that package from a central repository? If that is already there, no. But if it is not there, what it does, what Maven does, is it going to pull or basically is it going to download that Maven dependency from central repository to local repository? Yes. Similarly here, similarly here, similarly here, we have a local repository. Similarly here, we have a local repository. Here, if that image is not available locally, then it will pull from that central repository. Then it will create a container. That is how it is going to work. And what is this -p? Port mapping. So what is this port mapping? Why do we need this port mapping? Let me tell you. When we are creating a container, when we are creating a container, each and every container will have an IP address. Each and every container will have an IP address. Each and every container will have an IP address. Container will have an IP address. So this container will have an IP address. And container will run on some port. Because I am creating a container out of that Nginx image. Nginx image contains Nginx software. On which port that Nginx will run in this container? What is the port of Nginx? 80. Now, each and every container will get a container IP address. Each and every container will get an IP address. And using this container IP and this container port, you cannot access from outside. Outside in the sense from different server. From different server, you cannot reach this container directly. You cannot reach this container using this container IP and that port, using that container port, you cannot reach. Each and every container also will have IP address, and that container will listen on some port as per the software. Now from remote machines, from different servers, from other servers, we cannot reach this container. We cannot access that application using this container IP and container port. So that's why we are doing something called -p. We are doing something called -p, port mapping or port forwarding. There is something called -p, port forwarding or port binding. So what is this port mapping or port binding? There are two things here. There are two things here. One is host port. One is host port. Another one is container port. What do you mean by host port? First one is host port. What is host here? What do you mean by host? You cannot access like this. So that's why we are doing port binding or port mapping. What do you mean by host port? Host is nothing but your server. Host is nothing but your server. Host is nothing but your server. Any port available, any port available, any port available in that host, any port available in that host, right? We can use whatever port is available in that host. You can use that. Can be no need to be 80. Whatever port is available, you can use that port and you can map like this. Then, if I want to access like this, that application which is running as a container from a different machine, what you are going to do? You are going to use that host IP. What do you mean by host IP? Instead of container IP, you are going to use host IP and host port. What do you mean by host IP here? Host IP is nothing but your server IP. Your server IP. Host IP is nothing but your server IP. Host IP is nothing but your server IP. Then host port. Then request goes to this server and then the request will be goes to that container based on the port mapping. Then request goes to that container based on the port mapping. So that is why we are doing port binding. So is everyone clear what is this hyphen P option? Is everyone clear what is this hyphen P option? Now what is this hyphen D? What is this hyphen D? Detached mode. Detached mode. Detached mode. So hyphen D stands for detached mode. What do you mean by detached mode? In the background mode. Detached mode, in the background mode, which means container will be created in a background mode. Otherwise, if I create a container in interactive mode, the container will be started, and if I close this terminal, if I close this terminal, or if I close this terminal, or if I press Control C, that process gets stopped. That's why we are doing. Now let me do this. Let me do this. Now you observe what is happening. So this image is not there locally. This image is not there locally. So what Docker is doing first? What Docker is doing first? What Docker has done first? Since this image is not there locally, it is pulling. What do you mean by pulling? What do you mean by pulling? Pulling in the sense downloading. It is downloading that image. Downloading that image from where it is downloading. Since I have not mentioned any registry from where it is downloading from Docker Hub. Since I have not mentioned any tag also, since I have not mentioned any tag also from where it is downloading, what tag has been used? Colon latest. It has downloaded that image, and what else it has done? As I already told, what else it has done? It has created, it has created, then then it has started also. It has created a container and it has started the container. Now if you see Docker container ls, sorry, Docker container ls or Docker ps, both are same. Do you have some container running? Do you have some container running here? Now, sorry, Docker ps or Docker container ls. Do you have some container running here? Yes. Or if you see, that container is created out of this image. Is that image downloaded first to this server? Is that image downloaded first to this server to create a container? Yes. So the image is downloaded from the registry. Now what is running inside this container? You can see more details about the container also, something like this. Docker inspect this container ID or this container name. You can see this is the IP. This is the IP of that container, 172.17.0.2. Now within this Docker server, this container IP will work. Now, am I getting a response of that Nginx homepage? Am I getting a response of that Nginx homepage when I am accessing using container IP and container port 200, that Nginx homepage? Yes. But does this container IP and port will work from a remote machines? Remote machines in the sense other servers in the same VPC or other servers from the internet? If I use that, will work locally within the Docker. But now how to access remotely? How to access remotely? As I told, while creating a container, we have done something called port binding or port mapping. So we can use that host port and host IP. So what is the host port I have given? As per this command, what is the host port I have given? 80. Now I can use that server IP. That server IP. What is the server IP? That server has its own IP address. That server has its own IP address. You can see this server has a private IP, public IP. If it is a private IP, can we access from in? Can't access. But let me use public IP. Firewall in the security group. I need to open that firewall in the security group. Something like this. Something like this. I can open whatever host port, whatever I have mapped. That host port is 80. I have mapped that host port and I have opened that host port. Now, even though I am not mentioning port, the default port is 80. Now, am I able to access that application, that software which is running as a container now? Yes. But if you observe, did I manually downloaded, installed, and started that Nginx? If you observe, you guys might have installed Nginx last time. The way you guys installed, downloaded, and started, did I done the same way this time? No. So this Docker image contains required softwares and configuration to run that software. Using that image, I am creating a container. Similarly, similarly, I have lot of public images. Similarly, I have a Tomcat image. Similarly, I have a Tomcat image. Now, I can use this image. I can use this image. Different versions are there. Different versions. Tomcat 10.10, Tomcat 9, Tomcat 8, like this. We have different images. You can see Tomcat 8 is there, Tomcat 8.5, Tomcat 8.9.0, like that. We have different versions of the Tomcat images, these tags. Now, these tags, these tags are used to create a containers. Tomcat image with different versions, right? So this is there. Now I can use these images to create a containers also. I can use these images to create a container. Now I can create a container like this. I can create a container like this. But if I directly create a container out of this image, does my application will be part of this image? Now I am creating a container like this, something like this. Host port, I am doing something like this. Now I am creating a container out of this Tomcat and I am mentioning the version also, something like this, 8.8.0.20, 8.0.20. 8.0.20 JRE8. This is tag. If I don't mention this tag, what is the default tag? As I already told, latest. So it will going to use that image. Do I have that image also here? If I go to the tags, can I see that image here? If I go to the tags section of this repository, do we see something called latest image in that Tomcat repository? Yes. So this image will be used. Now I am mentioning this image. Now if you see, it is going to use this image. Now if required, you can only pull the image, guys. If required, you can pull the image first. But if you pull the image, does it mean that the software will be up and running as a container? If you just have an image in that server, I can pull this image like this. Docker pull. It will just download the image. But does container gets created? Does Tomcat will be up and running if I just pull the image like this? No. Just image gets downloaded. Image will be there, but it won't be running. The container will not run. Now, if you see, I have an image. Locally. But is that image is running as a container? If you see, when I say container ls, Docker ps or container ls, no. So if required, you can only download the image, but container will not be created. So what is container? As I told, container is a runtime process of your image. So I can do something like this now. Docker run -d -name container port mapping, something like this. Whatever port is available in the host. Now this image, Tomcat, I have an image locally. Since I have image locally, is it going to pull that image one more time? Since the image is already there locally, is it going to pull the image one more time? No. So it will create and start the container. Now Tomcat is also running as a container. Now let me access by opening that port, host port, whatever I have mapped here, 8080 port. Now same server IP, and what port? Host port 8080. Now am I getting a Tomcat home page? If you observe, Tomcat home page, yes. But did I install Java? Did I download a Tomcat manually? Did I start a Tomcat like that? No. So how come that is happening? Where is the Tomcat software? Where is that Java software? How come it is running? That is running as a container. If you observe, is it simplifying the process of running the softwares or applications as a containerized deployment instead of virtualized deployment? Yes. But now, is any application is running in this container now? Is any application is running? Do I have this application package? Any application like this application or any other application? No. So we don't have this application, any application running. Now we can use these images. Whatever images we have in the Docker hub, we can use these images as a base image to create our own image. Understand this point, very, very important. So we can use these images as a base images. On top of these images, we can create our own image with required code also. Now, if required, I can use this Tomcat as a base image, and I'll create another image with the Tomcat plus my application code. And if I use that image to create a container, will I have a Tomcat plus my application code? Yes. So we can use these images, whatever images is there in the Docker Hub as a base image to create our own image. Like this, we have a lot of images. You have some image called CentOS. We have one image called CentOS. We have some image called Alpine, like this. Now, what is this image? CentOS. Don't consider this as a full-blown operating system. This is not a complete OS. This is CentOS libraries to interact with kernel. This is CentOS libraries to interact with kernel. Don't consider this as a full operating system. We have something like Alpine. We have something like Alpine. This is also one image. Alpine is also one Linux distribution. One Linux distribution. This is again not a complete OS. It's a libraries. Guys, as I already told, whether you are using Red Hat, whether you are using CentOS, whether you are using Amazon Linux, what is that? It's a wrapper for your kernel. Kernel is important. It's a wrapper for your kernel. So you are using that CentOS libraries or Debian libraries to interact with kernel. But if you are using these images, it will not have a kernel. It will not have a kernel. It will not have a full-blown OS. It will just have a libraries to interact with kernel. Now, I can create a containers using this CentOS, or I can create a containers using Alpine, or I can create a containers using Ubuntu, like that. Now, if you observe, I am creating a container directly using that CentOS, something like this. Name CentOS container. I am giving image, this CentOS. Now, if you see, it is pulling this image and creating a container. It is pulling that image and creating a container and starting the container. But since that CentOS image doesn't have any software, any process which makes the container alive, is that container is running even though we created a container? Do you see any container with this name out of this image? If you see, do you have any container running? No. If you see, it is in a exited state. When I say Docker ps -a, it will display all the containers. When I say Docker ps -a, it will display all the containers. If you see, is that container is in exited state? This CentOS container created out of this image, is it in exited state? Yes. So now here, even though I am starting one more time, even though I am starting this container one more time, if you see again, is it in exited state? Why that is happening? Anyone? Anyone? Why that is happening? Because do you have any software or any process which is keeping the container alive? Do you have any process like Nginx or Tomcat or database or Jenkins or Nexus software like that which keeps that container alive? No. So just a CentOS libraries. So we don't have any software. That's why it is just creating and it is exiting. It is creating and it is exiting. Now we can use this as a base images. We can use this as a base images to create your own container. We are not going to create a containers directly out of this image because your application is running. Your software is running, but your application is not running. Now, if required, I can use these images base as a base images to create a container. Now, don't get confused. Even though I have installed Docker on Ubuntu, can I use these Alpine libraries? Can I use CentOS libraries to create a containers? Even though Docker is installed on top of Ubuntu? Yes. Because these are just libraries. These are just libraries to interact with kernel. These are just libraries to interact with kernel. So is everyone clear what is image, what is container, and what is registry? today, whatever has been discussed, the basics. Now we will try to see how to containerize our own application. Now I want to containerize my own application. Let's say you guys deployed this application. So many times you guys deployed this application, right? This application you deployed a lot of times. Did you guys deploy this application already manually when you learned Tomcat, and also using Jenkins also you have deployed? But how did you deploy this application? How did you deploy this application? You guys deployed in a virtualized deployment manner. Virtualized deployment. Virtualized deployment. So we can deploy this one. Last time we deployed as a virtualized deployment. Now I want to deploy this application as a container. So if I want to deploy this application as a container, what is first what we need to create? Can we directly create a container without image? No. So you guys done like this. You guys done like this. Last time, what you guys have done before I go to that question, Pandu, someone was asking this question. So Ansible is a configuration management tool and also pull and push mechanism. Is this correct? First thing. So Ansible is following what mechanism to do the configurations? It is following push-based mechanism. So Docker is a containerization software. We can build and deploy our applications. So when we use Docker and when we use Ansible, now here itself you are saying same thing. Ansible is a configuration management tool and Docker is a containerization tool. Is both are same? Your question itself has an answer. Ansible is a configuration management tool. Docker is a containerization tool. Is both are same? No. What is the difference between configuration management? Let's say you have hundreds of servers. Let's say you have hundreds of servers. Suppose I want to configure something that can be some OS patch, that can be installing some software like Docker. Let's say I want to install Docker in 10 servers. Can I use Ansible? Can I use Ansible to install Docker in 10 servers instead of doing one after the other? Yes. So Ansible is completely different. Ansible is completely different. So we can install or we can configure the servers using Ansible. That configuration can be anything. That can be installing some software or starting some software or deploying some application also. But here, when it comes to applications, you can deploy applications in a virtualized deployment and containerized deployment. So if you want to deploy your applications as a containers, what is required? If you want to deploy your applications as a containers, what is required? Docker. Now, using Ansible, can I connect to some Docker server and create a containers, create images like that using Ansible? Can I connect to some Docker server, maybe one Docker server or 100 Docker servers also if required? Can I create a containers in 100 Docker servers also using Ansible? Yes. So Ansible is a configuration management tool. You can execute, you can do the configurations, you can execute some commands in the remote machine. Docker is different, Ansible is different. But if required, can I install Docker using Ansible? Can I run some Docker commands in a remote Docker servers using Ansible? Can I run all these Docker run commands like this or Docker run commands like this in the remote Docker servers using Ansible? Yes. So understand the difference, guys. Understand the difference. Docker is different, Ansible is different. So when you are going to use Ansible, whenever you want to do some kind of a configuration, that too in lot of servers, you have a tens of servers, hundreds of servers in which you want to do some configuration or some deployment, then you are going to use Ansible. So containerization is different, configuration is different. I hope everyone clear. Now let's come to this topic. Last time, how you guys deployed this application? Let's take this use case. You have a source code. You have a source code. You have a source code. Now, last time, what you guys have done to deploy that application, you got that code. You got that code. You created an application package like this. You created an application package like this. You got an application package. You got an application package like var, jar, ear like that. You got an application package like var, jar, ear like that. Now, last time you have some system that can be your local laptop, that can be on-prem server, that can be some AWS server, that doesn't matter. So last time when you guys deploy this application, did you guys done like this? Is it possible to deploy this application like this as is without doing this step, without doing this step, without configuring that server with required softwares and libraries? Is that possible last time? No. So you guys installed required softwares and configurations and required environment variables. Then only you deployed this application. Now we know the problem. We know the problem. What is the problem here? You cannot run multiple applications. There is no isolation here. So that's why now people started using Docker. If it is Docker, how it is going to work? Now same thing, you are going to create one package like this. Along with this application package, what you are going to do? One more package, what you are going to do? You are going to create one more package. What is that package? If you are using Docker, you are going to create one more package. What is that package? This package we call it as a Docker image. Docker image. So that Docker image, I can create a Docker image with these two components. I can create a Docker image with these two components with required softwares and that application code. With required softwares and application code. Now, with the help of Docker, I will build the image. With the help of Docker, I will build the image. I will build the image using some Docker commands. I am going to build the image. Now, to build the image, you are trying to build your own image. What is the input for you to build the image? There is something called a Docker file. There is something called a Docker file. There is something called Docker file. So Docker image is a package. Docker image is a package. We can create a Docker image. We can create a Docker image with required softwares and application code. But how come Docker knows what software should be part of that image and what configurations, what code should be part of that image? How Docker knows? That image will be created with the help of something called Docker file. With the help of something called Docker file. So using Docker file, we can create an image. It's a file. It's a text file. It's a text file which contains instructions, to create a image. So daemon, Docker daemon will process, all the instructions in a given Docker file, to create a image. So to create a image. So using Docker file, we will create a image. Using image, we will create a container. So it's a text file. It's a normal file without any extension. So if you see this one, let me show this application. This application, the way we have a pom.xml. So why we are using pom.xml? Can I call pom.xml as a build script to create an application package like jar files, var files? Does Maven is using this pom.xml to build that package? Yes. So similarly, we have something called a Docker file. If you see, do we have something called Docker file here? So this Docker file is an input. Docker file as an input to create an image. Now this is my Docker file. In detail, I will explain what is from, what is copy, all these things. In detail, we will discuss. But if you understand, this is my Docker file. Using this Docker file, Docker file is a text file that contains all the instructions to create an image. It's a file. So as I told here in this document, Docker file is a file. It contains some instructions to create image quickly. The Docker daemon will run all these instructions in top to bottom and it will create an image. So Docker file is a source code for image. If you see, if this is my Docker file and if I create an image out of this Docker file, what that image will have? You can answer easily. You can see something here from Tomcat 8.0, something like this. Then copy our code. So if this is my Docker file, and out of this Docker file, if I am creating a image, my own image, so what that image will have, guys? Does that image will have Tomcat plus my code? Yes. So that image will have a Tomcat plus my code. Now, so from where Tomcat is coming? So what is this? This from Tomcat. Basically, we are setting this as a base image. So from where this base image is getting downloaded to create our own image? From where this base image is going to be downloaded to create our own image? That Docker Hub. So what we will be getting from this image? So from what we will be getting from this image, are we going to get a Java software? Are we going to get a Tomcat software also, along with some container libraries to interact with kernel? Yes. So we are going to get Java software, Tomcat software. So Java software, Tomcat software, along with some container libraries are coming from this image. On top of this image, we are copying our code, our var file to the image, to the Tomcat web apps folder. So using this Docker file, we are creating an image. So that image contains Tomcat plus my application code. And if I create a container out of that image, wherever I want to create, my application will be up and running. So Docker file is a file. It's a file. It will describe the steps in order to create image quickly. Docker file is the source code for image. What is image? As I already told, Docker image is a package. Docker image is a package that contains everything: required softwares, required libraries, environment variables, all those configurations. Now, this is a typical Docker flow. This is a typical Docker flow. So, using Docker file, what we are trying to do? We are building a image. We are building a image. So image is package. So what software, what application code, what configurations part of the image is depends on what? So what softwares, what application code, what configurations is part of the image, that depends on whatever you have defined in the Docker file. Whatever you have defined in the Docker file. Now, using Docker file, we are building image, and if I am running that image, what will be created? If I am running that image, what will be created? If I am running that image, container will be created. So, whatever is part of the image, that will be running as a container. So, from Docker file, you are creating an image. From that image, you are creating a container. But how to share those images with the multiple team members or in different servers? I want to deploy that application, that image. So how to share those images with other team members or other people? So where we can maintain those images, the Docker images, that Docker packages, we can maintain those Docker images in the registries. Docker registry, that repository. So we can do something like this. So we can create an image out of the Docker file. Then we can push that image. To repositories. We can push that image to the repositories, that repository. So this registry, that can be Docker Hub. I can maintain in a Docker Hub also if required, or I can maintain in ECR, GCR, Nexus, whatever repository. It's up to you. As per your application requirement, you can maintain that images in the private repository like ECR, GCR, Nexus, or you can maintain in the Docker Hub also. So that image will go and sit here. In that repository. Now, I want to deploy my application. Now, in my application server, now what is the software which is required? Only software which is required to run these Docker images. Now, I need a Docker software. Now, here in this server, if I execute some command like this, that container name, something like this, that port mapping, something like this. Instead of using Tomcat image, if I use this image, whatever image I created, in which I am maintaining, in some registry I am maintaining that image, if I mention this image details here, does this image will be downloaded to this server and container will be created out of that server? Here? Yes. So, in this container, do I have application plus required softwares now? Is my application will be up and running now if I use this image, my own image I created like that? Yes. So this is how typical Docker flow works. Now let's say I want to deploy in another server, production server. Now if it works in this environment, does it works in another environment wherever you have a Docker? If you pull that same image, and save, if you create a container? Yes. So do you have any differences in the application or configure these softwares and configurations here? Same image you are using? No. So this way it is consistent, repeatable. So is everyone clear? A typical flow of deploying any application using Docker as a containers. So theoretically I have discussed, practically I will demonstrate tomorrow